Calculate the pH of 10 to the power minus 3 molar solution of perchloric acid. So first I have that pH is equal to minus log the concentration of the hydrogen ions. In here I have the concentration of hydrogen ions 10 to the power minus 3. This means I have pH is equal to minus log 10 to the power minus 3. To be able to use the calculator to calculate this formula, I click first the minus, then the sign of the log, then I write 10, then this sign which is to the power minus 3, I click again the minus, then I click the 3. Finally, I click equal. This will give me that the pH of perchloric acid is equal to 3. Calculate the pH of 10 to the power minus 4 molar solution of potassium hydroxide. Assume that the potassium hydroxide solid dissolves completely. So we said that POH is equal to minus log the OH concentration of my solution. In here I have it 10 to the power minus 4, so the POH is equal to minus log 10 to the power minus 4, which is equal to 4. I need the pH, not the POH. This means we know that the POH plus pH is equal to 14. So the pH is equal to 14 minus the POH which is equal to 4. This will give me that the pH of my solution is equal to 10. Acetic acid is a weak acid. The pK is equal to 4.26. If 10 to the power minus 3 moles of acetic acid is added to 1 liter of distilled water at 25 degrees centigrade, what is the resulting pH? First, let's write the equation CH3 COOH in equilibrium with the hydrogen ions and the acetate ions. I have initial concentration. In here I have 10 to the power minus 3, which is 0.001. And I have, in that case, the hydrogen ions will be 0 and the acetate ions in the initial concentration will be equal to 0. That change, I will assume in here it is minus x, in here it is x, and in here it is x as well. Now the final concentration would be equal to 0.001 minus the change that happens, the x. In here it will be x and in here it will be x as well. We know that the Ka is equal to the concentration of the product divided by the concentration of the reactant. So I have hydrogen ions multiplied by the acetate ions divided by the acetic acid concentration. I have that the pKa value is equal to minus log Ka value. This means Ka value is equal to 10 to the power minus pKa value, which is equal 10 to the power minus 4.26. This will give me that the Ka value is equal to 1.74 multiplied by 10 to the power minus 5. The Ka is equal to the final concentration of hydrogen ions, which is X, multiplied by the final concentration of the acetate ions, which is equal to X, divided by final concentration of the acetic acid, which is equal to 0.001 minus X. Because I have a very small Ka value, I will ignore the minus X. This means Ka would be equal to X squared divided by 0.001. I have the Ka value, which is equal to 1.74 multiplied by 10 to the power minus 5 multiplied by the 0.001. This will be equal to X squared. If we take the square root of this formula, this will give me that X is equal to 1.32 multiplied by 10 to the power minus 4. Now I have the Now I have that the pH value is equal to minus log X. This means the pH is equal to minus log this value, 1.32 multiplied by 10 to the power minus 4 is equal to 3.88. Solution of 10 to the power minus 3 moles sodium propanoate is added to 1 liter of distilled water. If the pKa is equal to 4.87 for propionic acid, what is the solution pH? Assume that sodium propanoate dissolves completely. Propionic acid is a common constituent of anaerobic digesters. If the pH of the digester is equal to 7.6, what is the percentage of the total amount of propionic acid which is ionized? First, let's try to write the equation. I have CH3, CH2, COO, Na, plus water, will give me CH3, COOH plus NaOH. Initial concentration of sodium propanoate is equal to 10 to the power minus 3. We will ignore the concentration of water. Here I assume it is equal to 0 and here is equal to 0. That change will be equal here to minus x, here plus x, and here plus x. Finally, the final concentration will be 10 to the power minus 3 minus x, and here will be equal to x and x. I have P is equal to x squared products divided by the reactant 10 to the power minus 3 minus x. First, we need to calculate the value of Kp because here we have the value of pKa. We know that pKa plus pKp is equal to 14. This means pKp is equal to 14 minus the value of pKa, which is 4.87, equal to 9.13. So this is the value of Kp. We need the value of Kp, which is equal to 10 to the power minus bKp, which is equal to 10 to the power minus 9.13 equal to 7.4 multiplied by 10 to the power minus 10. We can see this value is very small value, so we will ignore the minus x and we will substitute here in the value of Kp. So I have 7.4 multiplied by 10 to the power minus 10 equal to x squared divided by 10 to the power minus 3. It will give me that x value is equal to the square root of 7.4 multiplied by 10 to the power minus 10 multiplied by 10 to the power minus 3. The x value is equal to 8.6 multiplied by 10 to the power minus 7. Remember, we need the POH first, which is equal to minus log x, which is equal to minus log 8.6 multiplied by 10 to the power minus 7 equal to 6.05. From that, we can calculate the value of the pH, which is equal to 14 minus the value of the POH, which is equal to 14 minus 6.05 equal to 7.94. This is the first part of the question. The second part, we need to calculate the percentage of the total amount of propionic acid which is ionized, assuming that I have the pH is equal to 7.6. Now first, let's calculate the unionized part. So the percent of unionized part is equal to 1 divided by 1 plus 10 to the power pH minus pKa multiplied by 100 converted into percentage. It will give us that the value of the unionized part is equal to 1 divided by 1 plus 10 to the power 7.6 minus 4.87, which is equal to 0.186. So the total ionized part is equal to 100 minus the unionized part, which is equal to 0.186. We will have that the ionized part is equal to 99.8%.